Hello friends, so here we will do 2022 physics paper. I think paper came into happened in two semesters, semester 1 and semester 2. So we have here semester 2 2022, which is of 40 marks and the time given is 1.5 hours. And I find the question paper to be very interesting. We'll start with so there are questions in section A and section B. Section A has all mandatory questions which are all MCQs. So first we'll begin with, it says choose the correct answer to the question from the given options. Free vibrations are, we have four options: the vibrations under the influence of periodic forces, the vibrations with larger amplitude, the vibrations when the frequency continuously decreases, the vibrations with a constant frequency and constant amplitude. And this is the answer, D. Vibrations with a constant frequency and constant amplitude is free vibrations in absence of any external forces. So diagram below shows that is second question, and this says the diagram below shows four sound waves. This sound has the highest pitch. Now for your information, I will tell you pitch is directly proportional to frequency. So more the pitch, more the frequency. If you see in these waves, which wave has highest frequency? I'll give you a moment to think about it. Yeah. So if you see B has the highest frequency. Okay. So frequency is opposite of T. Okay. So T is equal to 1 by F. F is equal to 1 by T. So if you see in this case, time period is lowest. Time period is from one peak to. So this is half wave and then this is full wave. So you can notice that this has more and more revolutions in lesser time. So this is the highest frequency, this is the highest pitch. The third one is the graph plotted for potential difference against current for ohmic resistors, which what it will have. So it says first one is curve passing through the origin, a straight line not passing through the origin, third is a straight line passing through origin, and a circle centered at the origin. The answer is straight line passing through the origin. So C is the answer. Now how do we do that? You know V is equal to IR. So V is directly proportional to I. Okay, so for zero voltage there will be zero current, right? So something like this the curve would be. Okay, depending on the resistance, the slope will vary. Okay, now next one. Fourth one is the main switch in the main distribution system is present in a live wire, a live as well as neutral wire. This is the question we are talking about. A neutral wire and earth wire. So the answer is the main switch in the main distribution board is present in a live as well as neutral wire. Fifth question is a conductor AB is kept along north-south direction of the earth above a magnetic needle as shown below. When the key K is closed then, so here the north-south are assumed to be from right to left, and so obviously east and west will be on the other side. So actually this is a two-dimensional one, so east and west are supposed to be something like inside the page and outside the page. Now if you see, this is the diagram, this is the correct one and this one is not the correct one. So when key is closed, what will happen is there will be a flow of current. So flow of current is always from plus to minus terminal of the battery. So the current is flowing from A to B. Now if the current is flowing from A to B, you should know how to find magnetic field. So what we do is we use right hand rule, wherein say you, and I'll try to explain it by using a diagram. So what you do is you have got a thumb here and you have got fingers here. My art is not too good. So if you point your thumb in the direction of the current, then the way your fingers swirl, the way your fingers swirl towards the palm, that is the direction of the magnetic field. So if you see, if I am taking the current from A to B and point my thumb towards B from A, my fingers swirl in the direction as if magnetic field is going inside and coming back like this in this direction. Okay, so since the compass is on the lower side, so further the magnetic field is inside the page. Okay, inside the page, I don't know if you your grade they have given the convention. Inside the page is represented as uh, crosses. Okay, so inside this, I mean, for the point at which the compass is kept, it is going inside the page. That means it is in W direction or the west direction, and the Earth's magnetic field is in north direction. So the combined resultant vector would be somewhere in northwest direction. But for our answer purpose, we have to say that in which direction the needle will go. Needle will go towards west. Some other sites and solutions have shown that as going towards east. But I really wonder, because if we are putting compass on the upper side of AB, then yes, then we can say the field is coming outside the page, and then this could be east. But as of now, the compass is below AB, so here the magnetic field seems to be going inside the page and coming from out of the page above AB. So it will be pointing towards west direction. Now next one is, I'll be more than glad to answer more questions you have, on this, or in case you have any doubts uh, or difference of opinion here in question number 5. Question number 6. A coil wound around a piece of soft iron can become an electromagnet. When? When the circuit is open, no, because when the circuit is open, there is no current, so there is no magnetic field. It really doesn't matter whether you have a piece of soft iron or not. So this is the coil, and there is a piece of soft iron inside. Okay, and this is connected to a circuit like this. Okay, so magnetic field happens only when a current flows in the circuit. When the current flows in the circuit, a temporary magnetic field is created because of the flow of current in the coil. So the piece of soft iron that you insert inside the coil is actually to increase the magnetic field. Okay, now next one, 7th. If water absorbs 4000 joule heat to increase the temperature of 1 kg water through 1 kg of water through 1 degree centigrade, then the specific heat capacity of water is, so what we'll do is, it's in joule per gram per centigrade. Everything is in joule per gram. Okay, so what we'll do is, this will be, wait for a second, I think it's refreshing. Okay, so so the question is, water absorbs 4000 joule heat to increase the temperature of 1 kg water through 1 degree centigrade. Then specific heat capacity, now we know that Q is equal to mc delta T. Okay, when C is the specific heat capacity, so C is Q over m delta T. Right, now Q is 4000 joules over mass is 1000 gram into delta T is 1 degree centigrade. So this will be joule per gram per centigrade, 1000, that is 4 joule per gram per centigrade. So C is the answer. Next is Eighth, water is used in car radiators because it is good conductor of heat. Okay, good. It conducts heat faster as compared to other substances, cools the engine quickly. Its specific heat capacity is very low, its specific heat capacity is very high. Its specific heat capacity is very high, so that it can cool the engine without a greater increase in its own temperature. So that is the right alternative. Though A is also right, it's a good conductor of heat. Or a bad conductor of heat, I don't know. I mean, that is a relative term. So I think D is the most appropriate answer. The heaviest nuclear radiation is alpha radiation, gamma radiation. I think this is beta radiation. Some mistake here. So heaviest nuclear radiation is. Let me check what are the correct options. Is alpha radiation. I presume other one is alpha, gamma, beta, and let me check what was there. Fourth one is what? Hmm. X, alpha, gamma, beta. So those were the options. So this is X radiation, alpha, this is beta. Okay, so that's a mistake here. So alpha radiation is the answer. Whichever is the alpha radiation, I don't know. I think here I have taken B as alpha radiation. The next one is to study the age of excavated material of archaeological significance. We study the rate of decay of an isotope of uranium, cobalt, carbon. Carbon is the right answer. So carbon C14 is called as radioactive dating. Okay, so you can date the age. You can find the age of the fossils or whatever, even people, so it goes by there is a complex formula for arriving at the age of the object. So from the date it's dead, so carbon is used for that. Section B. Now we have theoretical questions. The diagram below shows a magnetic compass kept closer to coil AB wound around a hollow cylindrical cardboard. After studying the circuit and the magnetic compass carefully, state whether the switch is open or closed. Okay. So what is the magnetic field? Now if you see in this diagram, you will notice that Earth's magnetic field points in, inside the page. It's in north direction. Okay. And the compass is showing us down. Okay. So that is opposite the Earth's magnetic field. That means there is a current in the circuit. For compass to have deviated from the Earth's magnetic field. So that is how we arrived at a conclusion. A is after seeing circuit magnetic as soon as switch S1 is open, S1 is closed. Switch is closed for the current to flow. Current will flow in this direction, and when again current is flowing in this direction, there will be a magnetic field which will be uh, opposing the Earth's magnetic field. So in this direction, so magnetic field will be as if it is coming inside the coming from here and going to this like this. Okay, so we have magnetic field on this side. Here we have on this side, so it's like this. Okay, we have current in this direction, so magnetic field will be uh, yeah, magnetic field will be inside the. It will be like this. Again, the same thumb rule. Thumb rule we will use. So what happens is current's direction is this. So thumb in the direction of current, and then magnetic field is from this point to this point. Okay, so it's as if it is going from here and coming to this point. This is the direction of the magnetic field. Okay, which is against the north direction. So compass deflects. The next is calculate the thermal. This is What is the purpose of placing the magnetic compass in the above setup? To find the direction of the magnetic field, or to, yeah, I think that could be the only purpose. Next is, give an important reason for copper to be used as a material for calorimeter. Now this I have put, Question number 2, answer 2. Second is, the reason for using copper is that it has low specific heat capacity. So the heat capacity of calorimeter is low, and the amount of heat energy taken by the calorimeter from the content to acquire its temperature is very small. Okay, because it has low specific heat capacity. So that's why copper is used in calorimeter. So it takes lesser heat for Q is equal to mc delta T. So if the C is low, lesser heat would be needed to find the delta T. Calculate the thermal capacity of 40 gram of water. Specific heat capacity of water is 4200. So how will you do it? Think for a moment. So you have 40 grams of water, while the heat capacity is given in joule per kg per centigrade. Okay. So we'll have to divide grams, we'll convert to kilograms. It will be 40 into 1000 into 4200. That is the thermal heat capacity. That will be 0, 0, 100, 100, 42 into 4. That is how much? Around, that is 168 joule per centigrade. Now you see the mass, the kg or gram dimension is ruled out. So what is left is per centigrade, joule per centigrade. So that is a unit for thermal capacity. Now we have this circuit given, wherein we have this current I flowing into 2 ohm, and that is question number A. Now question number in the above circuit diagram. So whatever this question number, I guess 3. The question number 3. And A part is, we have to find the external resistance of the circuit, we have to find current I2 and current I. Now if you see in this circuit, we have a battery, we have a 2 ohm resistor which is in series to parallel combination of 12 and 8. So first we will find R equivalent of this. So R equivalent of this two parallels will be 1 by R is equal to 1 by 12 plus 1 by 8. That is equal to 8 into 12 by 12 plus 8. I mean R equivalent I have directly arrived at. Okay, and this was the breakup. So that will be 96 over 20. That will be 24 are 80. And 164.8 ohm, and 4.8 ohm is in series with 2 ohm. So total resistance of the circuit will be 4.8 plus 2, that is 6.8 ohm. Now what we have to find is, we have to find current I2. Now you see that whether this is current I1 or I2, the potential difference will be same across the circuit. Okay, so this V will be same for 12 ohm and 8 ohm. So that means I2 into 12 will be equal to, I1 into 12 will be equal to I2 into 8, and we have I1 given as 1.4, that is 0.4. Okay, so that is 0.4 into 12 is equal to I2 into 8. So I2 is equal to 0.4 into 12 over 8. 4 2's, 4 3's, so that is equal to 1.2 by 2, that is 0.6 ampere. Now if you see that I is equal to, I is the current which breaks up into I1 and I2, so I is equal to I1 plus I2, right? So we have I1 and I2 given here, so I is equal to 0.4 plus 0.6 ampere, that is equal to 1 ampere. So one part is answered, total current I, and even B part is also answered. And external resistance is also answered, that is 6.8 ohm. So these are the three answers of this question. This is 1, this is 2, and this is 3. Okay, so this is A, this is B, and this is C. I'll be glad to answer in case of some questions. You can always write to me in comments. Now we have another one, which is question number 3, part 1. Part 1 says 3 wires with proper color coding are connected to the 3 terminals of a 3-point circuit socket. Match the colors of this. So A is brown, B is this, so A is going to be green. So A is green, A is green, B will be light blue. We have the third option, that this will be B, this will be light blue, and C will be brown. Okay, because A is the earthing one and B and C are the live and neutral wire. Third one is, second one is, why does it become colder when a hailstorm? After a hailstorm, then during or before the hailstorm. Now what happens is, hailstorm is snow falling from the sky, or whatever, you have some snow particles, that fall down on the earth. What happens is, when they fall down, they actually absorb heat from the atmosphere to melt. Okay, so because they absorb heat from the atmosphere, it becomes colder after the hailstorm, right? So during the hailstorm, the status quo is retained, but as the snow balls melt, they actually absorb heat from the atmosphere. That's why it's colder after the hailstorm. So you can write it in your own words. If two bodies, question number B, if two bodies have the same specific heat capacity, then they will always have the same amount of heat. If the temperature increases the same amount, state whether the given statement is true or false. If two bodies have the same specific heat capacity, they will always absorb the same amount of heat. If the temperature increases the same amount. Well, no, it all depends on the mass of the body also. So, because Q is equal to mc delta T. So all they are saying is that C is same. If the C is same, it all depends on the mass of the body. If one body is heavier than the other one, that will absorb more heat. So I would say this is a false statement. If they say if two bodies are the same size, then I'll say yes, it's a true statement. Next is a metal piece of mass 420 gram present at 80 degrees centigrade is dropped in 80 gram of water present at 20 degrees centigrade. Okay, in a calorimeter of mass 84 gram. If the final temperature of the mixture is 3 degrees centigrade, calculate the specific heat capacity of the metal piece, specific heat capacity. I think there's some misprint. So give me a moment, I'll get you the correct numbers. Hi, so if you see, I put correct values in for question number 3, part 3. So it says a metal piece of 420 gram present at 80 degrees centigrade is dropped in 80 gram of water present at 20 degrees centigrade in a calorimeter of mass 84 gram. If the final temperature of the mixture is 30 degrees centigrade, then calculate the specific heat capacity of the metal piece. So what we'll do is, we'll do this question here. Okay. So what is given is that in a calorimeter, the metal piece is dropped. So mass of the metal piece is 420 gram, which is at 80 degrees centigrade. So heat given by the metal is, the metal piece is at high temperature. We have 420 gram into 80 minus 30, that is delta T, mc delta T. So we have m delta T, we don't have heat capacity, which will presume as S, joules per gram per centigrade. Okay, and this is gram and this is centigrade. So that thing is adjusted. So what is left is, yeah, this is the amount of heat given by the metal, which is 420 into 80 minus 30 is 50. S is presumed to be the specific heat capacity of metal. Capacity of This we have presumed, this we have to figure out. Right? Now next. Now this is the heat given. Right? Now who is absorbing the heat? Who is getting the heat? The water is getting the heat. So how much water is there? There is 80 grams of water. Correct? 80 grams of water. So heat gained by water is 80, and what is the water's heat capacity? 4.2 joules per gram per degree centigrade. This I have written as per. Actually I can write joule, gram, minus 1 and also. Instead I have written per into. What was the temperature of the water? It was present at 20 degree, now it is 30 degrees. So gain in the temperature is 30 minus 20, which is degree centigrade. This is gram. So gram cuts gram, degree centigrade is degree centigrade, so it is joules. 80 into 4.2 into 10, which is 80 into 42. 80 into 42 would be 3360 joules. Third thing is heat gained by the calorimeter. Heat gained by calorimeter. What is the weight of the calorimeter? Mass is 84 gram. What is the specific heat capacity? 200 joules into 200 joules per kg. So we'll convert this to joules per gram because the weight mass of the calorimeter is in grams. So now this becomes joules per gram per degree centigrade, and the increase in temperature is, this is also at 20 degree, right? Increase in temperature is 30 minus 20. That is equal to 2 by 10, 1 by 5 into 30 minus 20 is 10. So that is 10 by 10 by 10 is 0. So we have 80 into 84 into 2, that is 168 joules. Now we know that heat gained will be equal to heat loss. The heat loss is happening in case of metal in an ideal scenario wherein there is no wastage of heat, right? So heat gained is equal to heat loss. What was the heat loss? Heat loss by metal was 20, 420 into 5, 420 into 50. I have not written the final one. Area on the metal was 21,000 joules. That is equal to 420 into 50 joules, right? 50 s joules. That is equal to 21,000 sj. S is the specific heat capacity. So 21,000 sj as joules is equal to 3360 joules plus 168 joules. Now this is simple arithmetic calculation. So this is equal to, let me add, this is equal to 3528. This is equal to 3528 joules, and S is equal to divided over 21,000. Now that works out to I is 0.168 joules per gram per degree centigrade. Okay, almost 7 times, 6 times, yeah, 0.168. Okay, that is your answer. Now next one, Rohit playing a flute and Anita playing a piano emit sounds of same pitch and loudness. Name one characteristic that is different for waves from the two different instruments. It is quality of the sound. Okay. If now the loudness of the sound from flute becomes 4 times that of the sound from piano, write the value of the ratio of AF. I think some misprint. Let me check. Okay, so this is loudness of flute is 4 times that of sound from piano. So you have to find amplitude of sound wave from flute and amplitude of sound wave from piano. Their ratio. Now we know that I'll do this question here that this is B of first. Okay. Now we know that loudness of the sound is directly proportional to amplitude square. So LF over LP is equal to amplitude of flute by amplitude of piano whole square, and this is equal to whole is to 1. Okay. Now the loudness of sound from flute becomes 4 times. So this 4 is to 1. So AF by AP is square root of 4 over 1, that is 2 is to 1. So the ratio of their amplitude is 2 is to 1. That is the answer of this question. Now next one, what is the defined pitch of a sound? Now we know, here I have pasted that answer. Pitch of a sound is determined by the frequency of vibration of the sound wave that produces them. So high frequency, for example 880 Hz is seen as a high pitch, while a low frequency, for example 55 Hz is regarded as a low pitch sound. Low pitch, low frequency sound includes a bass drum, thunder and a man's deep voice. High frequency sounds include a high pitched whistle, squeak and a child's voice. The loudness or softness of a sound is measured in intensity. So that is my response to question number C, pitch of a sound. Now the next one. Name two factors on which the force experienced by conductor carrying current placed in magnetic field depends. Also state how these factors affect the force. Now I'll tell you that force on conductor carrying current I in a magnetic field B with a length of L is actually IL cross B. Okay. L is the length element and B is the magnetic field, cross is the vector product. You have vector product in your torque section, moment of force. I think somewhere you have vector which is cross product and dot product in your syllabus. Work is a dot product. So anyway, without getting into the merits of it, what cross means is the direction of the magnetic field with the length element of the conductor. So the perpendicular part, both should be the 90-degree angle. Okay, so L cross B means it depends on three. One is the angle between magnetic field and the perpendicular to the length element, and second is current, and third is magnetic field. So F is directly proportional to I and F is directly proportional to magnetic field B. Okay, with the help of which rule you determine the direction of the force acting on a count? Using right hand rule of Fleming's. What is right hand rule? Right hand rule says that your first finger presents vector 1, second finger presents vector 2, and the resultant the force is presented by the thumb. So what is nuclear energy? Nuclear energy, again I have pasted the response here in text. Nuclear energy is a form of energy released from the nucleus, the core of atom made up of protons and neutrons. This source of energy can be produced in two ways. One is fission, when nuclei of atoms is split into several parts, or fusion, and nuclei fuse together. During fission, the combined mass of product nuclei becomes less than that of the reactant nuclei, resulting in a mass loss. This mass loss leads to liberation of nuclear energy. Okay, so fission is the process that happens in case of nuclear energy. Fusion is something that is still being researched. Okay. So after omission of a nuclear radiation, the atomic number of the daughter nucleus increases by 1. Identify the nuclear radiation. And B is after omission of a nuclear radiation, the atomic number of the daughter nucleus increases by 1. Identify the nuclear radiation. This nuclear radiation is beta radiation. I have answered it here. So write a nuclear reaction indicating the nuclear chain mentioned in B, which is beta radiation. So in case of beta radiation, I will write a sample equation. So presuming that parent with these mass and atomic number breaks into child of this mass number and this atomic number, and in the process an electron is released. Okay, so if you see both the equations are balanced, z plus 1, z plus 1 minus 1 is equal to z, a is equal on both the sides, this has no mass number. Next is write a nuclear. Okay. Next is what is the special name given to the parent and daughter nucleus when the radiation is emitted. Answer of 3rd D is isobars is the name of the special name given to parent and daughter. So isobars is the name given. They differ in atomic numbers or number of protons but have the same mass number. Okay, this is the answer to this question. Now next one. An appliance rated 440 watt, 220 volt is connected across 220 volt supply. I think it is 220 volt supply. Here by mistake I have is printed as 120 volt. It is 220 volt. Or it is 120. Let me check. Okay, so this is 220 volt. So we have to calculate the maximum current that the appliance can draw. So we have power here which is equal to 440 watts, and we have voltage ratings given as 220 volts. So what we have to find is maximum current that the appliance can draw. Now we know P is equal to VI is equal to I square R, any of this, or V square by R. Okay, you would have heard of these formulas. We'll use this one. So I is equal to P over V. That is 440 over 220. That's what I was thinking. 120 will work out to be a friction. Okay, so that is 2 ampere. Now we will use the third formula wherein we have I, we have P, we have to find R. So R is going to be P over I square, that is 440 over 2 whole square, that is 4, that is 110 ohm. That is the resistance. That was this part. Okay, this was B, this was A. Now next diagram below shows a vibrating tuning fork E mounted on sound box X. When the vibrating tuning forks A, B, C, and D are placed in the sound box Y one by one, it is observed that the louder sound is produced when the tuning fork B is placed on Y. So that means with this 4, you get maximum, you get a very loud sound. That means this is resonating with the source fork. Okay. So what is the question? What is the frequency of tuning fork? Tuning fork possesses the same frequency as frequency of B, which is 320 Hertz. It resonates when you are actually at the same natural frequency. So why does B produce a louder sound? B produces louder sound because B is there is a natural frequency of the with the tuning fork. So in those scenarios, the loudness is highest. Now next one, third A. From the graph of heating curve given below, state the melting point, the boiling point. Now if you see in this graph, if you see what is happening is with time at 40 degrees centigrade, we are supplying the heat, but the temperature is not growing. That means this seems to be the melting point. and at 120 degrees, I guess it's 120, 160 degrees. At 160 degrees, with time the temperature is not growing. So this is the boiling point. What happens at boiling and melting point? That the heat supplied goes in answering the latent energy. Okay. So you would have read about latent energy of ice, latent energy of steam. So whatever new heat you supply, that goes into hidden or latent energy. It doesn't increase the temperature. The next is B. Complete and rewrite the following nuclear reaction by filling the blank. So what do we see here? We have 235 on this side. We have 4 helium. This mass number is gone. So 235 minus 4 will be 231, and bottom we have 90 atomic number and 2, that makes it 92, and now that balances the equation. So this is 92 and this is 231. Okay, now we have question number 6, which says study the above figure, answer the following. Now this is the figure of a this is the amplitude xm plotted against time. Now if you see, the amplitude of the wave is declining with time, so this is called damped vibration. As amplitude is decreasing, tending to be zero, at some point it will become zero. So question number 1 is study the answer the following question. Answer number A is it's damped vibration. Answer number B, what type of vibration does the above figure represent? The medium around offers resistance or friction to the motion, so the energy of vibrating body continuously decreases, due to which the amplitude of vibration gradually decreases. Okay. So third, okay, that was A. B. State one reason. So B was the reason for which the amplitude of the vibration decreases, because there is a friction or resistance, and that's why there is a loss of energy which leads to loss of amplitude. Write an example of natural vibration. The natural body clamped at one point, when disturbed slightly from its rest position, starts vibrating. The vibrations so produced are called the natural free vibrations of the body. Now we have another question. A certain beam, we are almost at the last end of the paper. Okay. Now we have question number 6 ka part 2. A certain beam of alpha particles, beta particles and gamma radiations travel through a region of electric field produced between two oppositely charted parallel plates A plus B. So there is electric field in which all of these three are passing. Okay, so presuming these are the two plates, this is plus, this is plus, this is minus. Field is always from plus to minus, so this is the electric field, and here we are emitting three particles, alpha, beta, gamma. Okay, alpha, beta, gamma. Now you know beta has a good Q by M ratio. Alpha are the heaviest particles and gamma are pure energy. They are pure energy radiations traveling at the fastest speed. So now they are saying which are the above three has maximum speed. Gamma radiations has the maximum speed. Which one deviates the most from its original path? So beta deviates the most. Third one, which one does not deviate at all passing through region of electric or magnetic field? Again gamma radiation, because they don't have any charge. If a wire of resistance 2 ohm gets stretched to thrice its original length. Now this is the last question. Calculate the new resistance of the wire. What happens to specific resistance of the wire? So now I have answered B part first. So answer 6 third B is specific resistance of the wire remains unchanged, since it does not depend on the dimensions of the wire length or area. It is the characteristic property of the material wire is made of. So we know that we have the formula R is equal to rho L over A. This you would have read in your books, wherein rho is the specific resistance. So that means R is directly proportional to L and inversely proportional to 1 by A. So inversely is written as 1 by A. Right? That is why R is equal to rho L by A. Now what happens is the wire remains same. So all you have done is you have increased the length to thrice. So we will write R1 is the first resistance in first scenario, L1 and A1 were the properties in first scenario, and in second one we have R2, L2. Now you know the wire remains same, there is no change in volume, so L1 A1 will be L2 A2, and L1 is 3 times. So L1 is 3 times, sorry, L2 is 3 times. So 3 L1 A2 is equal to L1 A1. So A2 is equal to L1 gone, A2 is equal to A1 over 3. Right? Now we know that R1 is rho L1 by A1 and R2 is rho L2 by A2. The row is same, that gets adjusted. So R1 over R2 is, I'm dividing if you see here. So this A2 is denominator, this will go up. So this will become L1 A2, okay, and A1 L2. Now we know that L2 is 3L1 and L1 into A2 is A1 by 3 divided by 3L1 into A1. So A1 adjusts A1, L1 adjusts L1, we are left with 1 by 3 over 3, that is equal to 1 by 9. So that means R2 is equal to 9 R1. And what was resistance before? That is 2 ohm. So 9 into 2 ohm, that is 80. Right? That marks the end of this question paper. Very interesting question paper in 2022. Very interesting questions and lot of theory there, which you have to write to. Conceptually very good questions. So I think you have got to have very good preparation to do this kind of question papers, and we still have 2 months time, so please uh, get on your desk and study hard, and I'm sure you'll do great. In case you have questions or you want image file of these solutions, you let me know in comments and I'll mail it to you. There is no way I can paste it in the video, so I'll save this as a separate image file, and we'll have all of this what I've written here. If you want, I can send it to you. Great, thanks for being around. Thanks for sticking to this video for a long time. I know it's just stuff. Yeah. Thank you. Bye bye.